In this video, we will describe the distributions. Assume that we have the graph of a distribution of a quantitative variable, whether it is a stem plot, a box plot, a dot plot, or a histogram. We will describe the shape of the distribution. In this case, we will use the histogram. The shape of the distribution can be either symmetric or not symmetric. If it is not symmetric, then we say that it is skewed. There are two types of skewed distribution, whether it is the left or the right skewed. For example, the first distribution is symmetric. Most likely, we are not going to have perfect symmetry, but we will have somewhat roughly symmetric. So we will use the term symmetric to describe the distribution that is almost symmetric. For the second graph, since the tail on the left hand side is longer than the right tail, we would say that this distribution is skewed to the left because again the left tail is longer. For this third graph, since the right tail is longer than the left tail, we would say that this distribution is skewed to the right or right skewed. So, to recap, to describe the shape of the distribution, we would consider the two tails. If the two tails are almostly the same or equal in length and it has one peak in the middle, then we say that the distribution is symmetric. If a distribution that has the left tail that is longer than the right tail, and in this case it has one peak, then we say that it is left skewed or skewed to the left. It's a distribution that has a longer right tail than the left tail, then we would say that it is right skewed or skewed to the right. In many cases, we can just simply look at the box plot and determine whether the distribution is skewed left, skewed right, or symmetric. For example, we have a corresponding box plot to this histogram, but assume that even if we do not have this histogram, if we only have this box plot, we see that the left tail of this box plot is longer than the right tail, and so we would say that this distribution is skewed to the left or left skewed. It is confirmed by this histogram here. We're very much interested in describing the shape of the distribution because the shape of the distribution can also tell us something about the center and the spread. For the symmetric distribution, the mean and the median are almost the same and they are somewhere in the middle of the distribution. For skewed distribution, the longer tail will pull the means toward it. And so for the left skewed distribution, we expect the mean to be lower or smaller than the median because we assume that the mean and the median are in the middle and then the longer tail pulls the mean toward it. In this case, the left skew will pull the mean toward the left, and so the mean is on the left hand side of median. That means the mean is less than the median. And so with the same reason, we see that for the right skew distribution, the mean will be somewhere on the right hand side of the median. And again, this is because the longer right tail is pulling the mean toward it, making the mean go to the right of the median for the right skewed distribution. In this case, the mean is larger than the median. And lastly, for the box plots. The box plot is divided into 4 quartiles. The third quartile consists of the first 25% of the observation. The second quartile consists the next 25%. The next quartile consists the next 25%, and the next quartile consists of the next 25%. In a box plot, we start with the minimum on the left hand side, the maximum on the right hand side. The dashed line in the middle is the median, Q1 to start the box and Q3 to end the box. What this means is that from Q1 to Q3, this box consists or contains 50% of the observations. There are a total of 100% of the observation from min to max. Regardless whether this line is long or short, each of these quartiles contains 25%. So for example, from the minimum to Q1, there are 25% of the observations in this quartile, but also even though Q3 to maximum is shorter, it still contains 25% of the observations.